Hey, hello, and welcome to today's GFG problem of the day, Smith number. Let's see what the problem has to say. Given a number n, the task is to find out whether this number is a Smith number or not. A Smith number is a composite number whose sum of digits is equal to the sum of digits of its prime factors. Okay, so the problem becomes easy if we know how to calculate the prime factors of a number. Okay, so the ask is pretty much clear here, right? So for example, if n equal to 4, so what they are saying is, now what are the factors of n, right? What are the factors of 4? Factors of 4 are 2 and 2, right? Okay, the factors of 2 and 2, because 2 into 2 gives us 4, right? So the factors of 4 are 2 and 2. And what they're asking is, we want to calculate the sum of the prime factors. Now the prime factors of 4 are 2 and 2. What is the sum? 4, right, of the prime factors, and needs to be equal to the sum of digits of the number. So the sum of digit of the number is 4 only, which equals, right? So this is a Smith number. Let's take another example, right? Let's take another example now. 378, let's consider. Okay, so what are the factors of 378? The factors of 378 are 2, 3, 3, 3, right, and 7. So these are the factors of 378. Now, if we let's calculate the sum of digits of the factors, right? 2 plus 3 plus 3 plus this gives us 9, right? 9 plus 7, 11 plus 7, 18. Okay, the sum of digits of the sum of prime factors is 18. And what is the sum of this, right? 3 plus 7 plus 8, right? 3 plus 7 plus 8 gives us 10 and 18. So this again is a Smith number. 378 is a Smith number. Okay, and the number has to be a composite number. It need not be a prime number. Okay, so first of all, what would be, now if we want to calculate the sum of digits, the base function we should figure out, right? Now sum of digits, right? So it will be simple, pretty simple, right? Sum of digits, for example, right, is a function, and we have n over here, right? So what we'll do simply, how we calculate n greater than 0 in sum equal to 0, right? And what we do, sum equal to sum plus n mod 10, right? So if it is 378, n mod 378 mod 10 will give us 8, number 8, right? So we are adding into sum is 8 now, right? And then what we do, n divided by 10. So what will happen if we divide this number by 10? It will give us 37, right? It will give us 37. So again, if we do the same, n mod 10 will give us 7, this 7, right? This 7, and we'll add. So 8 plus 7, right? It will be, earlier sum was holding 8, right? So yes, so it will give us 15, right? And then we again divide by 10. So the number becomes 3 now. Now when we do n mod 10 again, 3 mod 10 will give us 3. So 15 plus 3, 18, right? So this is a base function, sum of digits. Now coming to the calculating prime factors of the number, of the given number, right? So let's see the code for this. So for example, now this particular, right, function is to calculate the sum of prime factors of a number. So if it is, let's say, 378, okay, so what we are going to do is, so what we'll do, if n is 378, then first we will see whether it is divisible by, first we'll find the factors of 2, right? Definitely. And when will the number be, the factor of 2 when it is even number, right? So what we are going to do, we are going to keep on checking, right, whether a number is like 2 is a prime factor of the number or not, right? So first, yes, 378 mod 2 is 0, right? So what we'll do, we'll what we are doing, this sum, we are having this sum variable which will be holding the sum of prime factors, right? Sum of digits of the prime factors of the number three, of the number n, right? So 2 first, yes, definitely 2 is a prime factor because it is divisible. N mod 2, n mod 2, right? It is divisible by 2, right? So we are adding 2 to the sum, right? And then what we are doing, we are dividing by the number by 2. So what it will be, the number will be 189, right? 189. So we are going to keep on going to do this operation until the number is not divisible by 2. So here 189 is not divisible by 2, right? So we're going to move ahead. Now, once we are done with this, right? What if the number was even and we kept on uh, dividing the number by 2 until it is divisible by 2, right? So we'll get an odd number, right? We'll get an odd number finally. So what we are going to do, we are going to start checking with I equal to 3. Okay. So now we'll see whether this n mod I, right? N mod I equal to 0. So I is 3 currently. So we are checking if it is divisible by 3. Yes, it is divisible by 3. It gives us 63, right? 63. And since it is divisible by 3, we'll add 3 over here. Sum of digits of I. Sum of digits of I, right? I is 3. So we have already seen sum of digits, right? The function sum of digits we have already seen, right? So it is, right, as I said, what we are doing, we are taking the remainder, adding to the sum, right, and then dividing the number by 10. So here 3, definitely 3 is going to be 1 only, right? Only 3, right? So we are adding 3 over here. Okay. Then again checking, we are going to check whether this number, the resultant number, is still divisible by I, right? Yes, it is divisible by I. So it will give us 63 divided by 3, it will give us 21, right? 21, 21, right? And we are again going to add sum of digits. I is still 3, right? I is still 3. So we are going to add 3 over here, right? Again, we'll check whether this number is divisible by 3. Yes, it is. What it will give us? 7. 7. Yes, 7. Yes, since it is divisible, 21 is divisible by 3. So we are again going to add 3, right? We are again going to add 3. Okay. And then what we are getting now, we are getting 7. Now 7 mod I, 7 mod 3, it's not divisible. So we are going to go ahead, right? And until we find, now this time we are going to find I when this will be divisible, right? When I becomes 7, right? I becomes 7. So here we are adding, when we'll be adding 7 here, right? When will this come into picture? For example, if the number is a bigger number, right? I, when I is 11, right? I is 11. So this will be like, it will give us what? 1 plus 1 equal to 2, right? Sum of digits. Sum of digits for 11 will give us 1 plus 1 equal to 2. We'll be adding into the sum here. Okay. So just an example of 11, right? Okay. And now, yes. So why we are going till 10 by 2, right? So a number, uh, like if you want to find the prime factors, right? So definitely it will be, will be finding a number which divides n till n by 2 only, right? N by 2. Temp is what? We are holding the original number of n, right? Because n we are modifying over here. We are modifying n over here, right? We are modifying n over here. So temp we are holding, right? N, right? So we are going to, so that is why we are going to, as we are going to find the factors till n by 2 only. So we are going till n by 2 only. And then I plus 2. Why we are doing I plus 2? Because the number is going to be odd only, right? The number is going to be odd only. Post this operation, each time the number, see, you have observed, it's odd, odd over here, odd over here, odd over here, right? It's so no, so no point in finding, for example, for finding prime factors for I4 or 6, 8, something like that, because the number is always going to be odd post this operation, right? That is why I equal to I plus 2. Okay. So finally what we are checking here, if post this operation, right? Post this operation, if still, right? N can be, n was what here? 7 divided by 7, it was 1, right? Finally. So if post this operation, right? Still the number was not divisible by any other number. For example, it can be prime, right? So 13. Finally, the number was 13. It boiled down to 13. Now, 13 cannot be divisible by any number, right? So, post this operation, if the number was not prime, then it would have been 1, right? It would have been 1. If the number was prime, so it cannot be divisible further, right? So here, if still the number is greater than 1, if the number is prime, we are returning here 0, right? Or else sum is what? This sum is this. What is sum? 2 plus 3 plus 3, right? Which gives us 18. And sum of digits of temp. What is temp? Temp is holding the original n 378. So we are calculating the sum here, right? Which gives us 18. If this is not equal, we are going to return 0. If everything is good, we are going to return 1, right? So this is a pseudo code. I hope you have understood this. Now let's see the same what I have explained, right? This is a code, right? So let me submit. Let me check. Yes, it is accepted. Thanks for watching. Please like the video and subscribe to my channel. Thank you so much.